The next problem I wanted to review in these opening slides was letter D. You can, as I mentioned earlier, do letter C on your own if you'd like, but letter D had some interesting things that I thought would be worth taking care of looking at together. 3 boxes are stacked onto a set of bathroom scales. The total mass of the boxes is 12 kilograms. The heaviest box weighs 6.5 kilograms. The 2 smaller boxes weigh the same amount. How much does each small box weigh? Okay, so we're trying to figure out the amount of weight in each of those small boxes. And this is what we know. The total of all the boxes is 12 kilograms, and the largest box is 6.5 kilograms. If we want to draw a picture of it, we would put, well, let's see. We would put, maybe make it a section. Could say this larger amount is 6 1/2, and there are 2 smaller boxes and they're supposed to be equal. This doesn't look equal to me, but they're both the same amount. So we could start by saying that this is going to be a bigger algebra problem. So we're going to start with 12 kilograms. And for right now, since the unit of measurement, they're both kilograms, I'm not going to bother with the label right now. But I'm going to start, and I'm going to start by writing this as 12.0, and I'm going to subtract out 6 1/2 kilograms. I'm actually going to do something maybe a little bit funny. I'm going to put them in parentheses. And I'm going to divide whatever I get for this answer, I'm going to divide by 2, because I've got 3 boxes altogether. One of the boxes is 6.5 pounds, and the other 2 boxes equal the same amount. Whatever I find for my answer will be the amount that each one of these smaller boxes is worth. Now you've got to ask yourself, do you like to see this as 6 1/2, or would you like to see it as a decimal? Again, I'd like to see this as a decimal, so I'm going to rewrite what I have. I've got 12.0, and I'm going to go down this way because I like to do subtraction going down. 6 half of 1 is 0.5, okay. And then I'm going to subtract. Oh, wow. I can't take 5 away from 0, so that means I've got to borrow. This is one problem I've seen a lot of people do, is they know that they need to give move a tenth or a 1 over here to this 0, but they don't often cross out the 2 and make that 1 or 11. So let's make sure that we do that. 10 minus 5 gives us 5. I'm going to just drop this decimal point down. And then we have 11 minus 6. Well, 11 minus 6. I could count up from 6 to get to 11, or I can just simply go 11 minus 6. Either way, I'm going to end up with 5.5. And I'm going to move this on down. You can see that I did everything in here. I'm going to put divided by 2 in here. Oh, Nelly. Now I'd like to do this as a fraction because that's what we've been working on. So I'm going to say 5 1/2 divided by 2. Keep, change, flip. So we have something more going on here than what I think you might be aware of. So let's make one thing. If we're going to be doing it this way, we've got to make this into a improper fraction. 5 times 2 equals 10, plus 1 equals 11. And we're going to keep that. That's the same. 11 halves is the same as 5 1/2. We're going to change the symbol to that, and we're going to flip 2 to 1 over 2. Got to be really quick because I'm running out of time. 11 times 1 is 11, and 2 times 2 is 4. I can take 4 into 11, and 4 goes into 11 2 full times, and my remainder is 3/4. Okay? The next problems we do will be for our step-in lesson on page 350.